The SummerCart64 is the first open-source flash cart for the Nintendo 64. It's able to play both released ROMs and homebrew software. It works with a variety of game save types, has real-time clock support, and is able to emulate the 64-disc drive. So, if you want a way to play your backup games, play ROM hacks of those games, or even create your own homebrew software, I'll walk you through how to make your own SummerCart64. Hello everybody, and welcome to the N Galaxy Workshop. Today we're going to be working on a SummerCart64. As already mentioned, it's a flash cart from the Nintendo 64. There's a couple of different places where you can get one, including the Phenom Mod Shop and Towstick64 shop. This will run you anywhere from about $108 to $134, depending on if you get a cartridge shell or not. However, if you have the appropriate skills and are up to the challenge, there is another way to acquire one. As this is a fully open source project, you can go to the SummerCart64 GitHub and get the files needed to order your own PCB from a PCB manufacturer. Keep in mind that this does involve some pretty advanced soldering and may need some special equipment. You can get assembly service where these components are already placed, but this will also add to the cost. Linked in the description below is the order page for PCBWay. There are 4 options that you'll want to make sure to check. Change the PCB thickness to 1.2 millimeters, click Yes for edge connector, beveling to Yes, 45 degrees, then ENIG for both the edge connector and the surface finish. Hard gold for the edge connector is recommended, but also has an almost 4 times price increase. This is also for a minimum of 5 PCBs. Next up is ordering the components that will be needed. I've included a shopping cart for both DigiKey and Mouser in the description below. There are extras included for some of the smaller components. These are pretty cheap, and it's helpful for when one of them flies off somewhere. Check to make sure everything is in stock before ordering. There is also a separate link for the USB to UART adapter that will also be needed. While you could just stick the PCB into the N64 and use it as is, a cartridge shell will make it much easier to insert and remove it, while also protecting your hard work. These can be picked up from a variety of different shops. I grabbed this transparent blue shell off of Etsy and this clear one off of eBay. I did have to modify it slightly to allow easy access to the SD card, USB port, and the button on the back. Included in the SummerCart64 GitHub is an STL file for 3D printing your own cartridge shell, which includes the proper openings. Finally, a label for the cart will go a long way making it feel complete. You could print these out yourself or order them online. I've seen a couple of Etsy sellers who will make custom labels. I've ordered mine from Towstick64. I've also placed links below to the tools I will be using for this project, including the microscope and soldering iron. When you're finally ready to start on this project, first thing you'll want to do is protect the edge connectors. Some Kapton tape will do just fine. I like to start with the smaller component first. Looking at the bill of materials page, there are 48 capacitors and 21 resistors to place on the board. For these, I hold them in place with some tweezers and then apply some solder to the tip of my iron. I will then solder to one side of the capacitor and then the other. Flux will be extremely helpful here. I start with one value, go one by one while checking the bill of material page for placement before going on to the next value. After all of the capacitors and resistors are in place, we come to the first component that we have to make sure we have the correct orientation of. The LED will only work one way. On the LEDs here, there is an arrow that is pointing in the direction of ground. When looking at the PCB, the ground is on the inside, here. The voltage regulator, TC1264 3.3V, can only be placed one way. These 2 pins are grounds, which can be pretty difficult to heat up properly for the solder to melt well. Once again, some flux will go a long way to help with this connection. With component U2 TPS2111A controller, we have to again check which pin should be placed where. When looking at the PCB, we can see a longer line here, indicating that this pad is number 1. Looking at the chip itself, there is also a small dot here that indicates pin number 1. When soldering a component like this, I'll get it placed where I want it, holding it in place with my tweezers. I will then add a small amount of solder to 1 or 2 legs. If I am still happy with the placement, I'll start soldering the other side before finishing up the side I began on. If the chip moves slightly while soldering those first legs, it's easy to heat it up again and move it slightly into place. I then add a tiny bit of solder to each leg and pad. If you notice some of the legs are bridged together, you can pull some of the solder down to the other legs. Adding more flux may be necessary. If all else fails, wick away some of the excess solder. Then repeat this step for U3 through U7, once again being careful to see which pad and leg are pin 1 before adding a bit of solder to one leg and then finishing up the other legs. I like to skip U8 for now and go on to U9. Components Y1, X1, and X2 are some of the more difficult components with only a soldering iron. For Y1, I apply solder to one pad, heat it up as I place the crystal. I then place the soldering iron tip on the other pad till it pulls solder onto it. X1 and X2 oscillators have 4 pads that are also hard to get to. Pin 1 for both of these are on the bottom left. If you get the same ones I did, it was much harder to see the indicator dot on the 12 MHz oscillator than the 50 MHz. I tin the right 2 pads, heating these up while I place the component. I then place the iron on the other 2 pads. Once again, flux is your friend here. Now is the time I like to place U8 on the board. This is a difficult one to get placed right for me, as my microscope doesn't zoom out quite far enough to see all of it without physically adjusting it. Once again, just placing a bit of solder on 1 or 2 legs and then checking placement before soldering down the opposite sides. Now that the most difficult components are finished, it's time to attach the USB port and the SD card holder. I place the USB port on the board and connect the leg before once again checking placement. After this, I'll add solder to the ground tabs on the other side before finishing up the other legs. For the SD card holder, I solder each pin in place before attaching the rest of the SD card. For the battery holder, I tin the pads and then heat up the tabs while pushing down and adding a bit more solder on top. Finally, the button can be placed on SW1 and all 4 legs soldered down. To make programming a little easier, I added in these pin headers. As is, they're a bit too tall to fit in the card, so I cut them down so they're just shorter than the button next to them. Now is a good time to go over each leg and make sure that there are no solder bridges and each leg is soldered into place. Now that the soldering is done, or if you've ordered your PCB with assembly service, it's time to pop in a battery and get ready to program. All of the software needed will be linked below. I'll be showing how to program on Windows 10 as that's what I use and have experience in. We can start on the SummerCart64 GitHub and scroll down to the build guide. We've already done a lot of this, so we'll head about halfway down until we reach initial programming. There we can download the FTDI programmer, the latest FTDI drivers, Python 3, and the files needed for the SummerCart64, which is v2.18.1 as of this recording. After extracting all of the folders, we can start to install the software and drivers needed. The CDM212364 setup file will install the drivers needed. Just follow the prompts. Next step will be the FTDI programmer. Finally, install Python 3. Grab a USB Type-C cable, connect your SummerCart64 and computer, and open up FTprog. If nothing is showing up yet, click on Devices and then Scan and Parse. This is what you should see. Note that under Device Output, all the bytes are FFFF. Right-click on Device and select Apply Template, then from File. Go to where you extracted SC64 Extra v2.18.1 and select the ft323h config file to apply. Right-click on the device again, and this time select Program Device. Now, when we look at device output, we'll see that the EEPROM has been programmed. Next up is the FPGA microcontroller and the bootloader. Disconnect the USB-C cable from the SummerCart64 and grab the serial UART TTL adapter cable. The cable I have doesn't have any labels on it, but going to the website I ordered it from, it has the data sheet with all the proper pinouts. Using some jumper wires, connect ground to ground, TXD to RXD, and RXD to TXD. After connecting the USB side to the computer, right-click on the Windows logo and open Device Manager to see what COM port is being used. Here, it's COM3. Connect the USB-C cable to the computer and SummerCart64. To make the next part a bit easier, create a folder on the C drive named SC64. Put the contents of SC64 Extra v2.18.1 and SC64 Deployer Windows v2.18.1 in there. Clicking into SC64 Extra v2.18.1, we should see primer.py, requirements.txt, and SC64 firmware v2.18.1.bin. Click on the Windows button and type in cmd and then open up the command prompt window. To change the directory, type cd space c:/sc64/sc64-extra-v2.18.1. Next, type or copy in pip3 space install space -r space requirements.txt to install the required Python packages. Next, type or copy in Python primer.py com3, where com3 is whichever port you noted in the device manager, and then sc64-firmware-v2.18.1.bin and press enter. Here it says to disconnect and reconnect the USB-C cable before continuing. After that is done, type in yes in all caps to continue. This will take a couple of minutes to complete. Once completed, your SummerCart64 is programmed, but we're not done just yet. Now is a good time to set the real-time clock on the SummerCart64. Find where you have SC64 deployer and set the directory on the command prompt window. I copied it into the SC64 Extra v2.18.1 folder to make it easier for myself. Since in the command prompt window I'm already in that directory, I can just run the command sc64deployer.exe set rtc. Now it's time to get the SD card ready. First, we need to download the menu. On the SummerCart64 GitHub, this can be found under the Quick Startup Guide. About halfway down the page is Running Menu in Standalone Mode. The N64 flashcard menu GitHub is linked, although by clicking here, it will take you directly to the latest release. Look for sc64 menu.n64, download and place it in the root directory of the SD card. Now is a good time to make sure that the SummerCart64 works in an actual N64. After turning on the N64, you'll get a screen stating empty directory with the correct time at the bottom of the screen. This will also create a menu folder on the SD card that we will be using shortly. Back on the computer, we can click on the main page of the N64 flash cart menu. Near the bottom of the page is a link to download the box art for every ROM. On the SD card, create a new folder called Box Art and copy all of the images to this folder. Now, when you go to boot up a game, it will have an image of the box art. If you wish to change the background wallpaper, have an image that is 640 by 480. Drop it onto the SD card and then go to this image and press A. It will ask you if you want to set it as the wallpaper. A again to confirm. There are a couple places online that have wallpapers already made for this purpose. A couple will be linked in the description below. Next, we're going to head over to 64dd.org, where under tutorials we can see how to add 64 disk drive capabilities to the SummerCart64. We can download the 3 files needed under 64dd IPL setup. Just copy over the 64dd IPL folders to the menu folder on the SD card. Now, all that's left is for me to copy over a couple of ROM files for games that I own. I've also added in a couple of ROM hacks of those games. Now we can put this into an N64 and run it. Well, except for maybe putting it into a cartridge shell first. While this isn't absolutely necessary, it does add to the finished look of the game. These will have to be modified due to the SD card and USB-C ports. You could download the STL files from the SummerCart64 GitHub and either 3D print your own or have one of the many 3D printing companies print one for you. If you don't need access to the USB-C or SD cards very often, you could just trim a couple of spots on the inside of the cartridge shell. However, for easier access, there will be 3 spots that you have to modify in a standard N64 cartridge shell. First, for the USB-C port, I start by eyeing where the port will sit and then make a couple of marks where I want each end of the opening to go. Then, using flush cutters, a craft knife, or a file, I slowly remove sections of plastic. When cutting with the flush cutters, I cut about 1 mm within my lines so I can then use a craft knife and file to get rid of any plastic areas stressed by the cutting. I then do the same on the other side of the card for the SD card, removing quite a bit on the back of the cartridge to allow room for me to remove the SD card. I then put the card together to test for clearance for the SD card and the USB-C cord. While the card is together, I make a small mark where the button is on the rear of the card. I then use a small drill bit to make a hole, slowly stepping up to larger bits until the button will fit in place. While the file for 3D printing the button is also included in the GitHub, I found that printing it as is didn't fit properly and I was unable to put the cartridge shell on the PCB, so I modified it to fit. I believe that the button on the back of the SummerCart64 is only to act as the eject button on the 64 disk drive, so this may not be necessary for most users. A couple of stickers can really finish the look. I got these from Tissot64. The front sticker was ordered with 0 clearance. While this might look okay with a standard cartridge shell, this sticker was too big for the shell I used. I ended up using a craft knife to cut around the recessed area of the shell to get the label to fit. I used the button cutout to locate where I should center the rear sticker, once again using the recessed areas to cut away the sticker excess. I would think that the 0.75mm clearance labels would work much better. Unfortunately, these were out of stock when I ordered mine. Congratulations! Now, with everything completed, the SummerCart64 is now ready for use in the N64. Using the SummerCart64 is pretty straightforward. Select which ROM you would like to use and boot it up. If you have an expansion disc, like for F-Zero X or Legend of Zelda Ocarina of Time, go first to the N64 game, select the file with A, but do not boot up the game. Instead, hit B, go back to where the expansion disc is located, and press the R button and select Boot the disc with the last selected N64 ROM. Booting up F-Zero X, we can see on the main menu that the expansion options are there. The SummerCart64 is a great tool for not only your game backups, but also homebrew games and tools. If you have a controller you just picked up, testing out the joystick in one of the many control test ROMs will let you know if the joystick module is in good shape or not. If you're into randomizers, you can place the ROM file onto the SummerCart64 and easily play it on original hardware. Same with all of the ROM hacks and translation patches that the community has put together. But what really fascinates me about the SummerCart64 is the ability to play original 64 disk drive discs and expansions. While there are only a handful of 64DD games that were ever released in Japan, effort has been made to make translations of these games available. While the SummerCart64 is already a pretty capable flash card, I'm looking forward to what else will be possible in the future with this open source project.